Okay, so I'm Will Iverson. I'm the CTO for Dev9, and we're going to be talking about, I called it the 1,000 ways to crash the VM, but we're going to be looking at both how the Java virtual machine can be crashed and then what some of the tools are that you can use to fix it. So first, a little bit about me and my background. But prior to Dev9, I worked at Apple. I was the Java and Runtimes product manager there. I worked at Symantec, working on developer tools. So if you remember a product called Cafe or Visual Cafe, I worked on that. I've been doing Java since 1995. So I actually started working with Java before JDK 1.0 came out. I've written several books on Java, a lot of articles, and this is my thing. This is what I do, is play with this stuff ever since then. Now, Dev9 is a custom software development firm based in Kirkland. So our offices are actually just on Park Lane, right down the street. And we build software using continuous delivery as the foundation. And most of what we wind up doing nowadays is building very large-scale, mission-critical, high-performance applications. So Java apps at scale is what we do. Apologies. Some of the projects that we do typically, actually I should need to update the slide because we've kind of moved away from .NET. So we pretty much do Java and JavaScript-based applications nowadays. One of the areas that for some reason we've done for several clients right now is identity management at scale. So clients will have us come in and build the identity service that ties together all of the different applications. And if that service goes down, then everything goes down. So that's why it's important to invest in a strong quality solution. We do a lot of SQL stuff, relational systems. It's almost like you talk about because it's so common. But we also do a lot of NoSQL work as well nowadays, which has been kind of fun over the last few years. Everything from graph databases to document store systems to some sort of, it's kind of a persistence, kind of a caching technology stuff. We're doing client side, Angular, Android, and iOS. We do DevOps, so part of our whole continuous delivery model is helping folks build and deploy things quickly, and that often means that we wind up having to work with operations teams on what is involved in supporting rapid deployment. And of course, one thing that we're starting to do a little bit more of now, more recently, is content management system implementations. And that's really more the web content management, not so much enterprise document management, if you're familiar with those spaces. But if you're interested in that, feel free to come and talk to me after. So, to start our presentation off, boom! Your app is crashing, it's exploding, it's dying, you don't know why, you don't know what's going on. So when we talk about these apps blowing up, for the purposes of the session today, we're going to talk mostly about web applications. So I know you were asking about Android stuff. I believe a bunch of this tooling does exist, and what you'll see is, even in a bunch of the tools, there's the options for doing remote connections, so then you have to get your network connection working between the device and the host. And it's a little more complicated on Android, but you already knew that. The other thing is that we're going to be probably focusing more on triage than on profiling. So anybody want to guess what the difference is between triage and profiling? All right. Anybody?
Yeah, triage. What went wrong as opposed to where the slow parts are and what's being used a lot and where the time went.
Yep. Yep, absolutely.
How it blew up the street.
Yeah, exactly. So a typical triage scenario would be the system's crashing in production and we don't know why, right? Profiling might be I'm running an app today and I want to find out where it's slow, I want to improve it. There can be some overlap between the two, right? If I'm doing performance testing and I crash the app, there's aspects of that is profiling because I want to know where it's slow, but there's also triage. Because if I blew it up when I did my profiling, I still need to figure out why and when. So profiling tools, there's a number of those, and we'll be touching on some of those tools, but we'll mostly be talking about the triage uses of those tools. Okay, so how or why does the Java virtual machine crash? Okay, I've got some examples up here. The core of it is probably the one that most people are familiar with is what is an exception or a Java error. And in that case, it's something that the JVM, the computer, the virtual machine, it basically has halted or killed a thread because that thread has gotten to the point where it doesn't know what to do anymore. So very common examples of that everybody runs into basically is when they start programming, things like a division by 0. Okay, well if that's not caught somehow, then it throws an exception, and then that thread can be put into a state where if the exception goes all the way up to the root, the thread basically is in this sort of dead state, right? So the threads become very closely tied in with the stack, right? So if I'm calling multiple methods and I'm walking things down through the stack, as I'm making multiple calls, something blows up and it bubbles up the stack. And maybe, if you're lucky, there's some sort of exception handler that's able to catch that and deal with it. So let's take a calculator application. So say you're making a little test calculator and you're building it in Swing or something. Well, you don't actually want that app to just die every time you divide by 0. That's not appropriate. So you could put a handler in that can, with a try-catch block, that can say, oh, I found that there was a division by 0, and I can sort it out and move along. But if the exception isn't caught and it bubbles all the way up to the top, the thread is then effectively in a dead state. So is that a crash?
And that's when a runnable actually exits. I mean, there's like one more.
Yeah, it probably would exit. That's what the root thread handler would do.
Like, yeah, okay, exited. You know.
Exactly. I'm dead. I don't know. So this is an interesting thing. When you run the JVM and it's just sitting there not doing anything, how many threads does it have? Or if I just say, I just want to print out one, I'm just printing out hello world to the console.
9 or some crazy thing, I don't know what it is.
How many threads? 9?
I don't know, some surprising number.
Yep. And that's because the JVM is doing a lot of background activity. And so technically you might actually wind up in a state where maybe your threads are dead, but the rest of the VM is okay. And then you get into this interesting thread management thing. That's where actually a lot of the application servers historically, that was one of the services that they provided, was thread management, right? So if I have, let's say I'm running Tomcat, which is the old a web server, right? So Tomcat is sitting there waiting for connections to come in, right? And so let's say a web request comes into Tomcat and it fires up a new thread and says, okay, this is the thing that's going to respond to that thread. Well, if that thread crashes, Tomcat basically says, okay, it crashed, I'm going to reap the thread and I'm going to move on, right? Finally, which is cool. That's what it's supposed to do, and it's actually probably, in my opinion, one of the reasons why Java is so popular for building web applications. Because a thread can crash, the server can say, bummer, and move on. If I'd written that same thing in C++ or C, and it crashed the whole server, now the whole server's dead, now maybe an ops guy has to restart the server by hand. That's like your worst case scenario. Which is sort of a nice segue into a different kind of crash, which is the JVM itself blows up. Now, that's generally speaking a bug in the Java virtual machine. And what's interesting is between Java 1.6 and 1.8, a lot of things that used to be would lead to hard crashes, the JVM has actually added protections for. So when we run this crash dummy thing, which I'll show you guys in a few minutes, we'll see a lot of things that will, like, the system will kind of pause for a second while it's sorting out what's going on, but it won't actually kill the VM anymore. So it's really kind of cool how robust it is. But the problem is that if you do get a hard crash where you've actually bonked so hard, you've dropped out of the JVM, you may be in a position where you're having to look at the native tools on the platform for debugging and sorting out what's going on. But frankly, at that point, you're probably in kind of deep trouble anyways, because you don't have the source and you're getting a native exception or failure, which means that you are now looking at a potentially extremely difficult to debug and diagnose issue. That said, in the last 10 years, pretty much any time I've seen that, there's the old joke about you go see the doctor and you say, doctor, my arm hurts when I twist like that, and the doctor says, well, don't do that anymore. And so I think that's sort of applicable with the JVM, where it's like, well, if you get hard crashes, just don't do that. Just figure out
whatever starts the whole.
Yeah. Exactly.
What should we use now?
Assuming you can find it, and that's the point.
Right, well, and that is the trick, right? If you have no way to isolate it or figure out what's causing the problem, then yeah, you're in deep trouble. That said, especially if you're mostly just building like a web service where it's really the network stack that you're interacting with, I have found it's pretty rare that you're running into that. In the old swing AWT days, I used to see that all the time because you were getting into all these bugs because of the way the windowing toolkits were interacting. Another problem, another JVM crash, typical one, is memory usage, right? So the way that typically will manifest itself is you'll get an exception back, some sort of out-of-memory exception. So in a sense, it's still like the exception above. Part of the difference is that the memory allocation stuff technically can kind of come up at any time, and it can kind of bite you sort of out of band of anything else that you've been doing. And then finally, the last one is CPU usage. And so CPU usage is one way to think of it on like a classic system is if I said, hey, I just installed my app onto this server and the app's running really slow. And then you go look at the server and you discover that the server is doing a bunch of other processing on things that have nothing to do with your app. It's not fair to say that your app is the problem, right? So with CPU usage, you can run into a similar thing even within the JVM, where let's say that you've got an app and you've written a Spring Boot app and it's doing most of the core processing for incoming requests, but someone else has added a background task to your Spring Boot app that's doing some cleanup thing. Now you have multiple threads running and contending within the same VM for CPU time. So how do you know and how do you deal with that? Make sense? Any questions about this? Okay. So here's some of the tools that you have. So here's your worst case scenario, and this is one where you really are looking at a cultural problem, probably not even a technical problem, which is you get nothing, right? So you hand your app off to an ops team, and the ops team tells you your app is terrible, it crashes all the time, and you say, okay, can you give me any logs? And they say, no, you're not allowed to access the logs, right? So I've been in environments that behave that way. So that's your worst case scenario. In that case, then you have to sort of get creative and start treating it really as a cultural problem. So don't have a lot more to say about that in this session, aside from it being a cultural issue. I would recommend going and looking at some of the other presentations that we've done on organizational design and things like that. Next step, logging. So as you guys know, there's a lot of very popular logging tools out there, Logback, SLF4j, the older Log4j, and they all let you control and tweak the levels of output that come from an application. The problem with logging is, anybody? What's the problem with logging?
If you didn't write down the right things, and it doesn't matter what you aggregate, it's not going to say anything relevant to what's causing your problem.
Yep. If you didn't put a logging statement in, it didn't dump anything out. That's one side. And then the other side is, if you log everything, things too slow to do anything, and you get too much noise, right? There's an old bit about one of the old application server vendors where people would download their app server for free, and then it would run really slowly when they'd go to put it in production. And so then they would charge you $500 an hour to come in and find the magic little places to flip switches to cut the logging down. And then all of a sudden your app's running 20 times faster. So yeah, it's a great gig if you can get it, right? Today what you'll see is there's some log aggregation tools. Splunk's a popular one. There's a couple of others out there that let you take log files and instead of putting them on disk, they stream them out over the network and send them to a centralized repository, and then they also do filtering and other analysis to be able to pull all the information together. That's okay, but even that kind of tool gives you the problem, which is you can only see what you've logged. And then if you turn the logging down because you were worried about performance, well then the problem is once you've gotten to a failure, it's too late to turn the logging back up to find out what's going to happen. Okay, so that leaves you with two more tools. So a thread dump and a heap dump. So who here's ever done a thread dump on a production app? Okay, you have. Anybody else? How about a heap dump?
I've seen them.
You've seen them, cool. Perfect. So this is a great session for you guys because we're going to walk through what those are and how they work. In fact, let's go ahead and look at the tools. I'm going to jump to the thread tools first. All right, so we're going to kick over and do some demo. This is demo time now, okay? So right now I have my little demo Spring Boot app. So we'll just start with that. So let's go ahead and let's start with the first command. So have you guys ever heard of JPS? JPS is the Java process listing. So if you have PS on your regular Unix machine, it tells you all the current processes they're running. JPS just tells you the Java processes they're running. All of these tools that I'm about to show, JStack, JPS, JConsole, JVisualVM, all of these are already sitting on your machine if you have the JDK installed. So you have to go do anything, it's just sitting there. It should be on your path already. If you can type java-version or javac and get the compiler running, you can get all these same tools up and running. Okay, so when I do JPS, it tells me the process number and this is the file that's launched, basically the command line that kicked off the process. So let's go ahead and do JStack on 19350. So this is kind of the worst case scenario, right? So what I did is I basically dumped out the current stack for all of the current threads that are running. So let's take, all right, here we go. So here we can see a couple of threads here, HTTP, new IO, 8080, execution 3, there's 1, there's 2, and there's 3. And so what we can see is that it is currently sitting in Java lang thread state waiting, and here is the stack, starting with the thread running, the task thread. This is coming from Tomcat, and then it's coming out of the thread pool, the queue, it's blocked, it's waiting, and it's sitting here waiting. And then up there you can see there's an attached listener. So what are we looking at here? What is this? Anybody high level, what are these threads doing? Any guesses? They're just sitting, waiting around, hanging out, waiting for a request to come in. So what'll happen is that there's one, I don't know if it's actually that attached listener, but I believe it is. And so what's happening is that basically the web server is just sitting there saying, hey, somebody might come in with an incoming request, and then it's going to hand that request off to a thread to do the work. Kind of cool. So this is a little bit like, being a cop on your regular police beat, where you're just walking around getting to know the neighborhood. Right? Because what we're doing is we're just sort of looking at what the JVM, when it's running our app, looks like when nothing really is going on.
And then there's the JVM threads in there somewhere. Or does it skip those?
No, we'll get to those. So there's actually the acceptor. So that's probably the app server acceptor, and the other acceptor I think is a JVM built-in one. And we can start kind of scrolling through and seeing, here's the root of the container. Here's a thread hanging out waiting to blow up the JVM, destroy JVM. Compiler. So these are a couple of threads where they're presumably hanging out waiting for code that needs to be compiled, and they'll pick it up. They may actually be running in the background, looking for things that have been run, and then when it hits a certain threshold, it might do a second or third pass compile to optimize the code. And here's the garbage collectors. So these are threads that are just hanging out waiting for memory that's been allocated that's no longer needed that they can wipe out for you. And here's the VM periodic task thread. So it could be anything. So that's your basic, most, this is the thread tool that you show when you're also talking to the kids about how you had to walk up, both ways, the hill and the snow to get to school every day, because when we were kids, it was horrible, and this is how we do it. Now, there's a couple of other tools. Let's see if console's even still available. So this is a little GUI tool called JConsole, and I can actually use this to attach to a running process. And this gives me some really basic telemetry off of the app. And so I could use these to attach to remote processes as well, but when you run it all local, it's really easy because it just auto-detects with the JPS what processes are running and then it's attached. And so here, I can click over here to threads, and I can get a nice list of all those threads. So we just saw those threads a minute ago, right? But this is a little bit nicer user interface for it, right? We also get to see how many threads are running. We can see what classes have been loaded. So this shows us how much Java code's been loaded by the system. I can go in here and look at a JVM summary. It's a little hard to read, but what's nice about this is I can go in and I can see, what the heap looks like already from memory, and I can also tell what arguments, if any, have been passed to the system. So in here I didn't pass any arguments to the VM, but the VM configuration and the arguments that you pass in can dramatically affect how the system runs, right? If I put you can override and say I want a smaller amount of stack, or I want to reserve a certain amount for heap. You can actually put the VM in a state where it can't run because you gave it the wrong arguments for configuration. So if you are talking to an ops person and you're saying, well, I want to know what you did to configure it, you can go in here and validate what's actually been done.
And this, so you don't have to echo out what you think you're starting with it in the back of the script that started it. You ask it when it's done, what did you end up with?
Yep. Well, maybe there's a bug in the boot script.
Yeah.
Mm-hmm.
No, that never happens.
Exactly, especially somebody handcrafted something. And then finally here, these are the MBeans. So, are you guys familiar with JMX at all? Have any of you? Okay, everybody's like, nope, I don't know what you're talking about. Okay, great. So JMX is an API that you can use to expose management interfaces. And so you can go in and you can actually find out information about your system through these management beans. So JMX is a fairly simple API, and it lets you expose things about your application to this management console. And JMX is actually a standard. So almost all the tools that an ops person's going to use that are, especially if they're focused on Java, are going to work with this API. So here, for example, I can see the default host that was set up on this Tomcat engine and its attributes. So on that CJUG list, when somebody was saying, hey, you should hook into this JMX thing and that's going to give you how much memory your app is using, that's the API. This is what it was. So there's a lot of stuff in here. Tomcat exposes out of the box a lot of information, and you can see all that over here. But even the basic JVM has things in it. There's attributes, the garbage collector. You can go in and get lots of information about the collector. Here you can see operations. So I can hit a button up here and force a garbage collection, for example. So it's kind of cool. Logging, if you use the Java util logging, I can go in here and I can tweak things. Now, one of the things that you can do, let's see how much this stuff is flipped on in this version. So this actually tends to change with major JDK versions. So the 1.6, the 1.7, and the 1.8 version and implementations of all this stuff move around a lot. So when you go from one version, that's the only thing that's frustrating. You're like, hey, I learned how all this stuff worked on 1.7, 1.8. Sun does, or Oracle, pardon me, does not consider the beans that are exposed to be, generally speaking, things that are preserved from version to version. So here I can actually see, hey, I want to dump out all the threads. And here I can see all my threads being dumped out in a completely different way. So this is JConsole. Oh, and here, JConsole itself blew up. That's funny. All right. So that's one tool. So here's another one. This one is also bundled with the JDK. So this is called Visual VM. And I can go in here and attached to it. You'll note that it's got remote, and then it can also load up other dumps as well. So it's a little bit nicer user interface. I can get to a lot of the same kinds of things. Here's a monitor. Here I can see how much heat my app is using, how many threads, classes, similar information. Now over here I can press the heap dump button. We'll come back to that in a minute. But here I can see my threads. And one of the things that is nice about this UI is that I can see the status of all the threads over time. Right? So I can, if there's a lot of churn, if I see certain deadlocks happening. Actually, we should probably fire up Crash Dummy instead of just this little Spring Boot app, just so we can see, we can actually start triggering some of these errors. Now, this tool also has the ability to do sampling. So let's go ahead and hit CPU sampling. And so what this is doing is it's watching your app, and it's keeping track of what's being executed and taking little snapshots of it over time. So when I hit stop, I can actually see what time is taking. And since it's not doing anything, there's not running anything, it's not doing anything very interesting. Let's see, profiler. The sampler and the profiler, basically they kind of do the same thing, except the sampler, the way it works is it just pings your app every couple, whatever setting interval that you specify, and then gets a snapshot. The profiler can be set up to watch everything that goes through. And so what you'll find is that the difference between the sampler and the profiler are 1 to 2 orders of magnitude of an impact to the performance of the app while it's running. Now what's funny is, of course, this is an i7 MacBook Pro, and if you're running just a simple web app and you're trying to do stuff, frankly, it's already got so much horsepower to it. You're not going to notice on this local machine a big slowdown, especially if you're just trying to isolate like one request at a time. Okay, so let's go ahead and quit out of that. Now I'm going to show you one more. This one's kind of funny. Okay. So let's do that. GPS. Okay. Now everybody knows the kill command. What command do you always do? -9. So kill -9 is the drop dead. I don't care what you're doing. I want that process done, right? So there's actually other levels of kill that are not -9. So if you send a -3 to a Java process, what it does is it does a thread dump for you. So if I go ahead and I do this kill -3 19350. Did I do the right one? Oh, that's because
That's that jar running.
that's the thing so this thing, because it's running in my little app, it's actually dumping it out to a log file. So
That's always the question, where did it put it?
yes, exactly. Where I told it to, of course. There you go. Oh, so it didn't do the heap, it did just this chunk of or it didn't do the threads, it did the heap here. That's different. There's probably another way of telling you to do that, unless it did it.
Is there more to it?
No, it didn't do it there either. Okay, moving on. Now, so we've done, this is some of the thread stuff that we've looked at, right? So you guys get why you want to check out the threads, right? Things are hung up. Let's go ahead and fire up. Okay. So now I'm firing up this little app called Crash Dummy. And we'll go to... Okay, so with Crash Dummy, what it does is it basically does horrible, horrible things that you should never ever do in your production or any app really at all. But it gives you a nice way of just clicking a button and creating the problem. Now, some of these aren't really germane for some of this perf stuff because they're just terrible ideas. Like, I can create a GUI window. Now, that's interesting.
You didn't finish that.
Oh, my app. That was my app actually bonking. Didn't like that one. Oh no, my little app's not working. No, that's terrible. It's not picking up the response.
There's something going on.
Now you have to diagnose it.
Exactly. I have to fix my bug. I have to fix my app that generates bugs. It's terrible. Oh boy. Just double check something.
Noticing the list. Set aside conversation. Is there any way to stop a third-party library from calling system.exit?
So the question is there any way to stop a third-party library from calling system.exit? Okay, here are some of the different things that I think you can do. I think it is possible to use the JDK security manager to basically put an access override on that method. So I think you can do that. At some point, you may be getting into a situation where you could even decompile a class or two and recompile it to just remove the offending. And I want to say that at some point they were talking about adding like a flag or something to avoid, to like basically treat system exits as no ops to the JVM itself. So those are in 3 levels of terribleness, not with, of course, skipping the obvious one, which is just filing a bug with your third-party vendor and they should fix it. But if you go to do that, if you're dealing with a case where it's an abandoned library, then I would say you might as well just recompile it yourself. And if it's not abandoned, then they should take it out for you. That's my 2 cents. Oh, Crash Dummy's not working. I'm not sure. Well, we'll have to keep trucking on here with the resolving the template. Yeah, it just is loading the template. Okay. All right, so I'm going to open up the Crash Dummy project so we can at least see what it's supposed to be doing. Okay. Yep, I was trying to fix something. That's what happened. Okay. So let's look at. So here's a dead thread generator, for example. This creates 2 threads, and then they both, in the implementation, rely upon each other with different synchronization blocks. And so in that case, basically, they get to this situation when you run the thread where it just says, hey, well, this thread needs that thread to move, and the other thread's waiting for the other thread. That's an example of something that sounds really bad in practice, but is actually almost trivial to detect. That all the JVM tools, you just hit a button and say, show me the deadlock threads, and they'll show you. So it's kind of funny because some of these are going to be really tricky to find and deal with, and others are going to be a lot harder. Let's see. Okay. So we were looking at thread tools and heap tools. Okay, so here's probably the if I was going to give you one walk away, like if you're going to just say, I don't remember what we talked about this whole presentation, but I remember one thing. There is a flag that you can set on the Java virtual machine to generate heap dumps for you automatically when you run out of memory. So go to your ops team or whoever and say, I want to flip that on. So that way when the JVM explodes from a out of memory issue, I'm going to get a heap dump out of it. So we'll come back to, we're going to look more at heap dumps and what that means. Now, you could use a tool called JMap. And what JMap lets you do is it lets you attach to a Java virtual machine and generate a heap file, which you can then use another tool called JHat that you can then do analysis on it. But that is essentially equivalent to using like command lines for everything, and it's really brutal. It's a very, very difficult way to work with the tool, and the heap analysis tool has its own weird query language that they invented. So it's not for the faint of heart, and there's really not much purpose. So what I'm going to do is I'm going to go back. Not sure it's a bad app, but it still is a running app. So instead what I'm going to do is I'm going to go ahead and fire up JVisualVM here. So sorry. Terminal. So let's see. Let's go ahead and attach to that. Okay. So what I'm going to do is I'm going to hit the heap dump button here. And what a heap dump is it is a copy of all of the memory that the JVM currently has allocated. And it also includes the thread dump as well. So it's the closest thing that you can get to a snapshot of everything that a JVM is doing at any given point in time. It's a static thing. So you can attach to that system and you can say, give me a heap dump, and it's going to generate out for you a list of all the things that are allocated and also show you the threads. So here I can see the threads when I click that heap dump button. I can also go in here and say, well, show me all the classes that were in use. You'll discover fairly quickly that most JVM apps, a huge percentage of their memory winds up just being character data, which makes sense because it's your config, it's the web page or the JSON response that you're sending back. It's just all this stuff, right? Let's see. Yeah, okay, so let's get the strings here. So here are all the strings that are in this JVM, and you can start seeing
content.
Yeah. And a lot of this is just going to be character data that's coming from the classes themselves. You know, these are all the error messages. This is all the things that are going on. You know, it becomes interesting when you then say, okay, well, I want to figure out which chunks of character data are the ones that are taking up a lot of CPU time. For example, I had a client once where they thought that they wanted to send back like basically about a half a megabyte worth of text every time that somebody hit a certain page. Well, it turned out that half a meg, because it was Unicode data, it's actually a full meg. And then by the time you added up how many threads you'd allocated and what the heaps were looking at, it was basically blowing up the system every time under load because the configuration didn't match the memory usage. And that was something that you could see really easily with one of these heap dumps, but it was hard to figure out what was going unless you had a tool like this. So let's go into one a little bit more specialized here. Let's see if we can find something interesting.
We had 3 2,000 concurrent references. What?
What's this?
You're still talking counts in the thousands for
Yep.
Spring Framework concurrent reference hash map. That's
Yeah, so
Who
let's
knew?
go. Yes. So let's go ahead and look at this a little bit. Here we can see all the here we can see, and it's like, yeah, what's in this map? And it's like, it turns out it's just references back into references, right? And you can hit this button called Compute Retained Sizes. So what computing retained sizes is doing is it's saying, well, I'm going to not just look at the local reference, but I'm going to figure out what things this thing is holding on to, and then it puts together the tree. So for example, here it's saying that there are 900 retained things because this reference in turn maps to this other reference, which has this other reference. So this, of course, gets back to the class loader. So the retained size often is how you track down what's really going on, because the other reference is just showing you the actual references, the actual instances. Does that make sense?
a hash map's a hash map, a hash map. The question is, what's in it?
What's it holding on to?
Yeah.
So if I have a hash map and the only thing in the hash map are a couple of references to some other instances, well, the hash map doesn't look that dangerous. But if it turns out that all those references are to 10 megabyte images, poosh, right? And so that's where you want to use tools like this to help figure it out. Now, what you'll notice, or at least what my personal take, is that while this is really cool and it's a good tool and it's free, so it's worth every penny, it's not as good of a tool as you might hope for. So, and as we are coming closer to the end of our presentation, I'm going to quit out of Visual VM and I'm going to switch to the first commercial tool, which is a package called YourKit. So YourKit is available, and I want to say it's a couple $100. I'm not a rep, so I don't know how much it is. I haven't checked it recently. But what it lets you do is I can go ahead and now attach to this local app. And what you'll find is that you get more detail and you get better detail. So here's the thread view. You'll note it's, I think, a little bit nicer to work with than the other one. Here's the deadlock detector. Here's the memory allocations. One of the neat features is I can hit mark current values. So I can say, record something, and then I can come back later and I can basically, let's see, refresh. Mark current values, refresh. It lets me capture snapshots and compare them to other usages later. Here you can see it's got different options for if I want to capture a snapshot. Right here you'll notice a little bit of an interesting issue. Let me go ahead and move the GUI around a little bit so we can see the dialogue a little bit better. Or not. There we go. It's kind of strange, but here it's got a couple of formats. You'll see this references to this HPROF format. This is the standard format that a heap dump comes in. And one of the nice things about that format is that you can open up heap dumps in different tools. So let's go ahead and take a snapshot. I'm going to go ahead and capture the snapshot here with the standard snapshot. And let's see, now I should be able to. So it's now grabbing a copy of it. It saved it in Snapshots Launcher. So what I'm going to do here is I'm going to So here's the cool thing, is I just took this snapshot here. I could actually open this up in JConsole. Or vice versa. I could be in JConsole, take a snapshot in HPROF format, and then I can send it to somebody with YourKit and they can analyze it later, which is kind of neat.
Is there a way that your code can ask the JVM to take a snapshot?
Yeah, use the JMX. The JMX gives you an interface for that. Does
Some
anybody-
UI is controlled, it's a controllable JMX.
Yeah, so once you know how the JMX tree works, you saw that JMX view that we were looking at with JConsole. So those are all available programmatically. So anything in there, your app can ask itself. Does that make sense? So one of the options is to say, take a snapshot, and when you do that, you can even pass in what path you want the file to get dropped to. It doesn't have the option, whenever you do a heap dump, programmatically or with one of these tools, it always drops it to a file on disk. And partly I think that's because of just a optimization thing. Because really, as near as I can tell, what it does is it basically just pauses all the threads and then just does this direct dump of whatever's in the memory right onto disk. Which, as a side note, is one of the reasons why I would recommend, and actually we're going to get into tips in a minute. It's one of the nice things about having smaller Java applications, but more of them, because then it's easier to triage them, right? So let's say that I have a whole bunch of microservices, but I do let them hang on to some working state, but they're really intended to be stateless. Well, if I set them all up to be 4 gig of memory allocations, right? And one of them blows up and it does a heap dump on out-of-memory error, which is the flag that you pass into the JVM. If I do that and it's a 4 gig of memory allocation, then it's going to create, give or take, a 4 gigabyte file on disk, because that's how much memory it was allocated. Well, if I have 128 gigs of memory allocated to a process and it blows up, that's what's going to generate on disk. And even if you have a couple of terabytes allocated for scratch space for those apps, you're going to blow it up really fast. And then you just get into even the basics of how do you work with it, right? So if I say that if the ops guy says to me, yeah, this app's having some memory problems, what do you got? Oh, well, it's a 4 gig file. They do tend to compress pretty well, so you zip it up and it's, a gigabyte. Okay, cool, I can put that on a little zip and hand it to you, or maybe I can put it on Dropbox or whatever. But if you start getting into 100 gigabyte files where you're trying to move them around, it gets really painful really fast. So here's the heap dump. I just went ahead and told it to go ahead and start calculating out the retained sizes. And you'll note it lets me do that multiple times because it's continuing to see how far it walks down the rabbit hole for all the reference chains. Yeah.
What does it do? Everything should lead back to a class loader.
Yep.
So it would count everything, references everything.
I believe that it does eventually all track back, but I don't think it uses that for purposes of the
It
calculation.
knows to skip JVM type references that would make everything reference everything.
Yes.
Whatever.
Except that, as you saw, things like maps and stuff like that, it's surprising how much references everything really quickly. But yeah, it's not going to use the class loader route. That's how it finds everything, but it doesn't use that for the
It knows
calculation.
not to go around in a circle there.
Right, because otherwise it would just say allocated memory, right? So it's smart enough to do that. Let's see, generations. Oh, this doesn't have the generation stuff. This is where your kit says if you take a snapshot in our proprietary format, we capture more info about the JVM. So this is just an HProf, which is the standard one. They added some stuff for web applications here. I haven't played with that. Ages, stats. This is a little more useful. It's got package organization. So here I can see that this is the stuff that's actually related to my app. That's something that the other one doesn't have, which is kind of, I was like, oh yeah, relation like that.
It's probably me, not the standard stuff, so let's look there. That's what that's for.
Yeah. Let's see. So this is this particular one. Let's go ahead and take a snapshot in their format. And then we'll get a little bit more information out of it. Now, this directly gets into an issue about dealing with production apps, which is, so here it's cool because I can have this profiler attached and I can get more information out. But it's a different conversation when I go to an ops person and I say, hey, I'd like you to put this little agent on. And so that's where the profilers generally all work, is they add a little agent to the system, and then that gives them instrumentation. If you're so inclined, you can actually do a little bit of JDK hacking yourself. You could say, I'm going to redefine the object class in the JDK itself, and you can put it as a privileged boot class where it overrides the default one, and you could use that to do your own profiling if you wanted to. I wouldn't recommend it, but you can kind of get a sense of, like, if I put an agent on this path, I can do anything, right? And so that's why most OpsCat people, if you say to them, hey, I want you to put this profiler on, and it needs this agent, as far as the ops person's concerned, they're not running the same JVM anymore, because they don't know what it's going to have or do. HProfs and the standard thread dump stuff, one of the things that's nice is that you can get all that stuff straight out of a JDK install, just straight from Oracle. There's nothing special that needs to be installed. It already works exactly. Yeah, go ahead.
Are they also present in OpenJDK?
Yeah, as far as I know, yeah. Those tools are really such core pieces of the VM plumbing. It's one of the things where, so Java will be 20 years old later this year, right? And that comes with some pros and cons. You know, if you are the cool kid at the coffee shop, you're like, oh, this is an old thing for old fuddy-duddies or whatever. But all of this tooling, not just to have one, like the standard stuff that's built in, but then also the third-party market and all this rich space. This is, I think, one of the reasons why Java is still so dominant in enterprise systems, because it has access to all this stuff. So for the OpenJDK, you know, I'm not even sure how they build the OpenJDK without some of this, because you need some of this plumbing. Like back when Sun was doing it, they use this stuff themselves. That's where, like the old JHAT and JMap tools, the ones that I was saying, you know, that sort of basic primitive stuff, they use those tools to build the JDK. That's how they took their testing on it. So it is an assumption, because I've played with OpenJDK at different points, but I've just got Oracle on here. As far as I know, they have all those tools. Played with that.
Okay, about that thing that you mentioned, it was such a bad idea, which is redefining one of the basic Java classes.
Yeah. Well, actually, I would say it's fun for educational purposes. I think if you're playing around with the JVM and you want to learn how it works, it's fun for that. If I ever saw a developer hand me an app that said, well, for this app to work, you have to, yeah, no, thank you.
There's some of the...
Sorry, you were saying, Steve, yeah.
Well, I'm going back and saying, I can remember cases where patching one of the classes in the Java package could have proven very useful, but I didn't think that was allowed.
It's allowed. There's this thing called the endorsed directory, and then you pass in a command line argument with the jar file that you want to have. Because what happens is when the old JDK would run, there was an rt.jar, right? Mm-hmm. And you could basically say, I want this jar to be loaded before rt.jar. And so, because there's actually an interesting issue here, right? Which things have gotten a lot better about lately, but it used to be that people would have the same class defined in multiple jars, right? You know, somebody would say, hey, I grabbed something from Apache Commons and I stuck it in my jar because I didn't have to worry about somebody else going and grabbing the same jar and putting it in. But then two different companies would do the same thing, and the next thing you know, you've got two versions of the Commons library loaded. They have the exact same path and package name, but they're different versions. So, yeah, and so the class path would then allow you to define the same class multiple times, and then you could just, whichever one you got was defined first is the one that would get loaded. There is an API in where you can say, hey, given this class, where is its source? So in the little crash dummy thing, which alas isn't working here yet, there is a little utility where you can actually type in the name of a class, and it tells you the name of the file on disk that it loaded the class from. And that's just available from the class loader API. So you can just say, hey, class loader, where did this object come from and where was it defined? And you can use that to help triage those issues.
I'd like to know more about that API.
Sure, it's in, well, you can see my sample stuff. It's up on GitHub, I think.
All right.
Info, it's in here, info, class file locator. There you go. Class for name, protection domain, get the code source. And so what happens is if it returns null, then it's usually coming straight from rt.jar. But otherwise, it gives you the location. So that's what you need right there. All right, so let's see, to finish up. So we covered heap tools, and we covered thread tools. Oh, so a bunch of the IDEs, specifically NetBeans and Eclipse, both have profiler tools that do a bunch of this kind of analysis stuff too. And one of the things that's interesting is they all do have slightly different feature sets. So depending on your issue, you may like one or the other. My experience has been that YourKit is sort of the granddaddy of all these tools because it is a paid tool. So they pretty much have everything. And we talked a little about these agents, okay, and the thread tools. Okay. So over the last 10 years...
So, did you say JHat, JMap, or one of those was an agent, something that you have to add to start up?
So both JHat and JMap are built-in JDK tools, but those are the sort of like command line horrible ways of doing it.
Okay.
If you're the sort of person that just uses Telnet to talk to an SMTP server to send your mail, then go for it. But if you actually want, like, I would just say just use one of the other tools to generate the heap dump, and I'll give you the heap dump and the thread dump, and then open it up in one of these other
But
tools.
some of the profilers have these agents that do extra work during...
Correct.
Right? Is that where these agents come from?
Yep. So like YourKit has an agent that you can install on a server, and then you can do things like remote attach to it. You can have it sit there in a low, sort of in a low monitoring state, and then you can attach to it and say, now I want to crank up or crank down the monitoring capabilities. But what you'll find, my experience has been is that if you go to an ops guy and you say, hey, I'd like to figure out what this production problem is, can I put an agent on and attach to it with my tool? They just laugh at you. So that's part of why I would put the focus on generating thread dumps and heap dumps on those environments, and then copy them off, and then you can analyze them as you wish. And that's part of where, like, you might want to generate 2 heap dumps. So YourKit has the ability to do diffs between 2 heap dumps. So you can, if it's like a staging environment or something, you could say generate a heap dump right now, then go ahead and do the thing that causes the problem, and then generate a heap dump when the problem manifests itself. Then you pull down both heap dump files, which, let's say that you have 8 gig allocated. So you pull down 16 gigabytes worth of heap files, and then you open them up in YourKit, and YourKit will tell you what the deltas are between those. That's actually pretty cool. And that's part of why I wouldn't really bother investing a lot of time in a tool like JHat or JMap, because you're just going to beat your head on the wall with these really opaque, arcane tools when even JVisual VM is going to be better. And frankly, if you're supporting a live production environment and you can't come up with a couple $100 to buy a copy of YourKit, plus there is a 15-day or 14-day or something free trial for YourKit. So, okay, so we talked about heap and thread. Everybody remembers the one thing, which is turn on that heap dump on out of memory flag for your prod systems. Okay, last little bit here as we're wrapping up. My experience has been that most of the performance problems that you'll see in a modern Java app are actually not in the Java app itself. It's something to do with the persistence that you're working with, right? You know, hey, we did all this monitoring on why the app is slow, and it turns out that the request spends all of its time just sitting there waiting for the database to come back. Very common. This is an older tool. There are a couple others that are out there. One of them that I liked a lot was called P6 Spy. Actually, they've updated this thing recently, so it's nice. It's got some newer features in it. And what this is it's a JDBC driver shim. And so what that lets you do is say, every time a request comes in or goes out, I want you to log in to the database. And it'll tell you what statement it was, and you can even flip on a flag that will do things like, if it takes more than 100 milliseconds for this request to come back, do a stack dump on the request that generated the long-running query. So depending on what persistence tool you're using, if it's Hibernate, Hibernate itself is going to be doing a lot of work for you. You can get a stack and at least find out where in your Hibernate code it's generating that. If you're using something like myBetas, which by the way, there's a video up on myBetas and Hibernate, you should check it out. Then it'll be a lot easier to diagnose and figure out what's going on. But this tool will give you a nice report that'll tell you this is what's taking a long time. You can tell it you only want to log things that take a certain execution time. If you tune it right, there's no reason not to leave this running in production. Certainly in development, it's a great package. So if you go to this link below for Cascade TG, there you can find links to the tools and download it. Because for a while, P6By you couldn't find. I think it's been brought back to life over the last few years as a GitHub project. It was kind of an abandonware on SourceForge thing for a little while, but now it's come back.
How easy is it, you call it a shim? Is it something after the application's all there and compiled and built, you can say, put the shim in, or what?
Yeah, basically, all you do is you just say, you put this P6 library on your path, on your class path, and then you say where you would go to define your JDBC driver, you basically put like P6By : or whatever for the JDBC URL as the driver. And so then what happens is then P6By gets loaded, and then it just passes in the rest of the connection information to the real driver. So the config is, if you've ever configured a JDBC driver, you can configure P6By. It's exactly the same thing. It's just a JDBC URL. And then the only thing that you do is you can pass an extra little property information in for what the path is that you want to drop the file on, and what your thresholds are, and stuff like that. So it's really easy to work with. And what you'll find, is that it's very common for it to be 2 or 3 orders of magnitude more processing time spent on your persistence engine than in your JVM app. Okay, so we talked a lot about things about blowing up and problems and what do you do. These are sort of some of my guidelines that I would say for thinking about persistence and thinking about state and thinking about how to build apps that you won't be sitting there reaching for your kit all the time. So one of those is stateless services. Spring Boot is sort of the poster child, like I said, for that, but even Spring MVC and modern REST interfaces, those stateless services are great because you move from thinking about state as something that sits in your Java app to something that is instead persisted out and lives in another place. So I actually have another video on session management and how to approach it, which you can find on our site, where I talk about how to deal with some of the state issues. But just by way of example, think about something as simple as a shopping cart. So that used to be a classic thing where people would allocate a shopping cart and they'd hold on to it in memory. Well, the problem is that it turns out that your shopping cart is sort of this infinitely persistent thing anyways. I put something in my shopping cart and I put it in save for later on Amazon, and I can come back 3 months later and that thing's still hanging out in my shopping cart. Amazon wants to know the metrics and the data about when I put something in there. So even there, something that classically would have been regarded as ephemeral is really actually a essentially lives forever system. So what that means is that if you keep all the state out of your Java app and you put it into a persistence tier, then that means you can also shoot your Java instances much more quickly. And if one fails, it's not as big of a deal, and containers and microservices and blah, 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 and there's another whole session there. Okay, but you get the idea. There are a bunch of key value data stores out. There are certain kinds of session caching information that you might want to do. So let's say, for example, you've got, there's an example of something, an ad inventory service that I worked on at one point. And so they wanted to hang on to all this ad inventory, and they had a lot of really complex calculations that they would use to determine what the inventory was, but then the inventory just sort of hung out in this sort of cached system. Well, we didn't put those caches into our Java application. Instead, we put them into other systems And so that way, those caches were persistent and survived the Java applications itself even being restarted, right? So, you'll kind of fall into this by accident. You'll start saying, hey, it was like really easy to just take a map, and then I have a hash map, and then I just start throwing stuff into it, and I've got this really cool little cache thing. Well, that can really come back to bite you in the bum later. So be careful about that kind of stuff. Don't really just use, the Java hash map to store everything. Use something for realsies. The next one is, I've been surprised at how often a perceived problem in the app is actually just a problem in the rendered HTML. I've seen it where it might take, half a millisecond for the page to come back, but because the HTML is written poorly, it can take 3, 4, 5 seconds for the HTML to render. So, open tags that don't ever close, and maybe an image asset that is slow to load, but there's no height and width defined on it, so the page doesn't know what it's supposed to render like until it finishes, or else it times out. On and on. A really bad example of that are some of those little stateless, or those little 1-pixel transparent trackers. So people will put a little 1-pixel transparent pixel tracker on for an analytics tool, but that little graphic will be slow to load. And so then what will happen is the page will sit there looking like it's not done loading, even though literally everything else is done, and it's just trying to get that one stupid little thing off your analytics package. So I suppose if it's all of you guys are Java developers and you're writing Spring Boot, and there's a hipster kid who's writing all your Angular front end, you don't care, because it's not it's the kid's view, except the problem is you're still going to get called because, hey, the app is slow. So you want to get used to using some of the tooling for the browsers, which we're not going into, to do performance, and really think about holistically, all the way from the beginning all the way back to the response. So those are just some tips. Last bit. All this stuff's way easier if you use test automation, and there are annotations even in JUnit for timeouts. So if you have anything that's performance sensitive, you can put that on, and you can also add these little JUnit rules for micro benchmarking and set assertions on performance critical things in your code if you want to. And on that works very nicely with a perf environment. We can do another whole session on performance testing, using something like Gatling to generate load, or Newstar if you want to generate 1 million threads of concurrent load. But from a high level, if you can't automate this stuff, eventually you're going to get to the point where you can't afford to ship because it's too much work. So you have to invest in the automation, so that way you'll be able to ship in the future. Because once you've been through a couple of things like, well, we had this bad performance bug and it took down the system. Well, now you suddenly are creating fear about shipping because you don't know if it'll come back because you didn't write an automated test suite for your perf testing. Make sense? Q&A. So thank you guys. It's a little teeny bit warm in here, but we got through this in about an hour. Any last questions? Yeah, sure.
Is Crash Dummy on your GitHub at this point?
It is. Let me go up. So if you go to the Dev9 website, actually I was going to wait to make it public until today. So we go to our GitHub account. I don't think I made it public. Let's see if it's public.
But it wasn't working, so you've got to...
Yeah, I got to fix it.
Tonight you'll get to make it public.
Exactly. Nope, there it is. So it's public. And then here's the persistent build runner.
What's the name of the app? Your demo app that does bad things?
Actually, hang on. I'm going to make this public. All right, so Maven Watcher's public now, and so I just made that public, and there's Crash Dummy.
Thanks.
So dev9.com is our GitHub account for complicated reasons because of the way how long the path is and stuff. But there you go. So it's all available. Yeah. If you want to fix my bug and then submit a pull request, go for it. It'd be awesome. I'll take that as a to-do tomorrow. Any other questions? Was this helpful? Did you learn any tools kind of cool? You guys are like, I don't know. All right.
So you revisit all these.
Yeah. Well, guys, thank you very much for coming today. I know it's a beautiful day outside, so